Hello, good um, afternoon by a little bit. I am Aubrey Digital, and I am currently in Calculus 2, and I am working on homework and studying and just trying to help myself to grasp the material by maybe putting it out there. So bear with me. I love you. Weird thing to say to somebody right at the beginning of the stream, I guess, but I appreciate anybody who watches my channel ever. Oh, I almost forgot. Today, oh, wow. Hey, thank you. You have a wonderful um night, I think it is for you right now. Um, I'll see you later. Thank you for stopping by. I love you. Bye bye. Okay. How nice. How nice. Oh yeah, I was gonna turn on music. Oh, okay. Cool. So you're probably just getting up. Okay. Yeah, it is 1 p.m. here. Just working on some calculus before I go to work. Um, yes, I have to get this done actually. Yeah. Hey, you gonna cook some breakfast? Thank you. Yeah, well, I already did it. I'm just kind of redoing it to help. You don't eat breakfast. So you mean you're just gonna make breakfast for everyone else, or you what else are you gonna feed them at 6 a.m.? Oh, okay, okay, okay. Duh, makes sense. Okay, sorry. So you're probably gonna feed them hay, I would assume. I don't know. I've never had a horse. That's so cool. Aw. So you're feeding the animals breakfast. Yeah, that must be a fun life you live. That would be awesome. I wish I had a whole, because you have like your whole your own like ecosystem. Fuck, that is so cool. I'm so jealous of you. Yeah, it sounds like a lot of fun. I bet it can get out of hand though, right? I would be scared of a horse getting out of line or something. I don't know. Like I said, I've never really had animals like that, especially. I have a little, or an old little kitty cat running around here somewhere. Okay, so cool. Um, when are you streaming next? All the time. Okay, cool. Well, I'm definitely gonna have to tune in. Probably after my midterm, which is Thursday. So Thursday, I'm gonna be looking for you on the stream. Oh, okay, cool. I can't wait to get more of a glimpse of your animals and your home and your area. Okay. So this problem is actually from my assignment. Yeah, heck yeah. I'm so excited. I'm gonna play some more new stuff and then, you know, the favorites as well, the classics, the hits. Sorry, I don't mean to be such a loser. I just can't help it. Anyways, have a great day, and I'll see you later. I love you. Okay, on to the name of the game. I made this new logo for myself. Anyways, so this is supposed to be from my partial fraction assignment, but really you don't need partial fractions because you can just use a u substitution, meaning we're going to turn this into u and this into u prime. So it's going to work out like this. Now we need our derivative of u squared plus 1. That's what this little tick is for. You could also write this as the derivative of u with respect to x, du dx, but we're just going to write it like this. So the derivative of x squared plus 1, a constant number just goes away when you take its derivative. So it's going to become 0. So we're just not going to write the constant number. But our x2, the 2 is going to come down, and this power is going to go down by 1. So it's going to become 2x to the first, but we don't need to write that. And then we can just do it like this. Rewrite our integral, and we'll say u squared times u prime. So we'll put the 1 in there with that. So it's going to be 1 over u squared times u prime, or the derivative of u. So luckily we can just rewrite this as the integral of u to the negative second, because anytime that you have, like, say, 1 over x to the third, that's equivalent to x to the negative third. You just reverse the sign. Well, take, you just add a negative to the sign, and then you can take it out of the denominator and put it on top. Okay. Anyways, so we've got u to the negative 2 times u prime. And so we can now take our derivative and, or not our derivative, I'm so sorry. We're taking our antiderivative. So, and that's what that thing means. The antiderivative, instead of, like, when we found the derivative here, we took away 1 from the power, but the antiderivative is just backwards. So it's going to be u to the negative 1, and then instead of bringing down and multiplying, we divide by our new exponent. So that gives us u to the negative u to the negative 1, which gives us 1 over negative 1 over u plus c, because we have to add a arbitrary constant number. And Now we can just plug in back in our u, and we should have our answer, I think. We'll check it. Equal -1 over x squared plus 1 plus c. And unless I did something incorrect, that should be our answer. Oh, you see, I did make a mistake. How about that? So, what happened is I forgot that because our derivative is equal to 2x and not just x, we have to move that 2 to the other side. So we're going to divide the 1/2 and to make that just become x. So that means I needed to have this tagging along outside of our derivative the whole time. Mm, dun, dun. Okay. And that is our final answer. So all you had to do different was bring a half along for the whole thing, and then after you integrate, times that 1/2 by your integral, but you don't actually like times it. It's not gonna, you're not gonna make it like u over -2. You're gonna keep it where it's at because you know you're gonna use that to flip it to that, right? So let me just add parentheses for clarification. So we have -1 over 2u, which translates to -1 over 2 x squared plus 1 plus c. Okay, now I hope I ate my Wheaties today because this next problem's a real doozy. Full disclosure, I did not eat any breakfast today. However, I did just eat a ridiculous amount of salad. Okay, I'm gonna see if I can get this one done before I want to end my stream. Gonna be a little short today, but that's okay. So, like I said, this is from our assignment regarding partial fractions. So thankfully, they've already factored our denominator for us. So when we say that we want to get partial fractions, what we're saying is we're going to make each of the factors a partial fraction. And now, since we have a number squared plus 1 in the second expression, we're going to have to kind of mirror that. Well, I guess it's not mirror because it's not squared. But we're going to do bx plus c over x squared plus 1. So basically what this is doing is just breaking it up into two different problems so that it's easier to take the antiderivative of it. Okay. So we take our first factor and we put it under a. If the first factor was something like this, then we would put it under bx plus c. But not, since it's not the second, it's just the first power of x. So we don't have to worry about it. And then we take our second factor, which is x squared, and that's where we're going to put bx plus c. If it was just x plus 1, we would just do b over x squared plus 1. So now that we have our partial fractions, let's go ahead and just, well, I'm trying to keep this kind of clean to look at somewhat. So now we've got our partial fractions. We can just go ahead and multiply each side by what it is missing, because, oh yes, I'm sorry, we're not going to multiply it by x squared plus 1. We're going to multiply it by x squared plus 1 over x squared plus 1, because then we're actually not doing anything at all to the problem. It's just times 1. X squared over x squared plus 1 over x squared plus 1 is just 1. So that's pretty cool. Anyways, the whole idea of this is to get rid of our denominators, so it just renders them meaningless. Because, I don't know, because they're in both expression. Like if you have 2/5 plus 8/5, you can just get rid of the 5 altogether because it's just 10. It doesn't matter if you have the 5. No, that's not true. Okay, don't mind me. That was a stupid analogy. That didn't make sense. Then it would be 10/5 or 1/2. Okay, not what I meant to say. Anyways, so my point still remains the same. We're still going to do the same thing. Let me clean up how this thing looks, though, because, like, what the fuck? Like, Aubrey, get it together. No. Okay. Now, hmm, I feel very unconfident. Not confident? I don't know. I don't know what the word is I'm using. Anyways, so this is one of the last concepts we were learning, so it's a good thing I'm reviewing. Okay, so that's what we're going to end up with. Oh shit, not B. Okay. Oh, I wrote this wrong. Okay. Thank you for your patience with me. Okay, so we're gonna still have our original problem. But we're not gonna have the denominator anymore because everything is times by the same thing. So let me try to redo that analogy. So what if we have 2/7 plus 3/7 is equal to, so we could say that 2/7 plus 3/7 is not equal to 17/7 because 5 is not equal to 17. But we could say that these two are equivalent because 9 and when 8 plus 1 is equal to 9. It has nothing to do with this. It's all strictly having to do with this. So this is why we're able to get rid of our denominator because it's all multiplied by x minus 1 and x squared plus 1. Anyways, okay, putting together the pieces here. Make this look better. No. All right. Oh, wow. All right. We got 3x plus 1. And then we have that this is equivalent. Okay. So now what we have here is a system of equations. There are a couple different things we can do to find out what our variables are. Okay. So first of all, whenever you have your factors like this, you know that that means that positive 1 is going to be a factor. But with this one, there's nothing that we can do. Like you think, oh yeah, I could just make it equal to, I could make x squared equal to -1, but no, you can't. Anything squared is going to be positive. So even if you had -1 squared, it would still equal +1 plus 1, and you'd have 2. So there's essentially nothing you can really do with that factor. So we're just going to take our +1 from here. We're going to set x equal to 1, and then we are going to have 3 times 1 squared minus 1 plus 1, which is equal to 3, is equal to x squared is 1 plus 1 is 2. We have a times 2 plus b times 1 plus c 1 minus 1, which is c of 0, which means that's gone. Or wait a minute. I'm sorry, I did this incorrectly. Okay, so just kidding. So, I mean, this whole expression is going to be times by 0, 1 minus 1. Okay, that makes more sense. Okay, so x plus c times 0 is going to be 0, so it's just going to be a of 2. To solve for a, now we can just go ahead and bring the 2 to the other side by dividing it by 3. So we have our a, we still need to figure out our b and our c. Now we're able to do this using the degrees, in which case we can say there's a 3 in front of the x squared on the left-hand side. And then we can say there is a, oh shit, 1 second. There's a little bit more work we have to do. So let's go ahead and just multiply these in together. Ax squared plus a plus, oops, FOIL, plus bx squared, fuck, minus bx plus cx minus c. So that's going to be our answers, or our numbers distributed into one another. So now we're going to have the 3x minus 1 minus x plus 1 is equal to ax cubed. So now we can say we have a 3 in front of the x squared here, we have an a in front of the x squared here, and we have a b in front of the x squared here. So we can say a plus b is equal to 3. And then we can say first power of x, we have a negative 1. On the other side, we've got a negative b and a positive c. So let's just write that as c plus, or c minus b. Now, constant variable, I mean, not a variable, constant number. So we've got 1 is equal to a minus c. So now we can use the variable we already found, which is a. So we can say 3 halves minus c is equal to 1. So we can subtract the 3 halves. And we'll say that negative 3 halves is equal to negative c. So we can get rid of the negative. And now we've got our c. And we can use a again if we want and figure out that, let's see with this one, 3 is equal to 3 halves plus b. And now we can subtract the 3 halves. So 3 is the same thing as saying 6 over 2. So 3 minus, I mean 6 over 2 minus 3 over 2. It's going to be 3 over 2? That doesn't seem right. Oh, weird. What did I do wrong? Weird. Okay. Let me try this in a different one to see if it's just. Okay, we're gonna try this one now. So -1 is equal to 3/2 minus b. So we can add the b to that side, and then we can say 3/2 plus 1 is equal to 5/2. So that would put b at 5/2. Unless I wrote this wrong. Oh, wait, it's a minus c. Yeah, it is a minus c. And it's a positive a. What the fuck did I do wrong here? Minus b, a minus c. Um, yeah, I think the tutor led me astray on this answer. I may not be doing this right. What a bummer. What a bummer. Fucker. Okay. I really thought that was how you did it. 3. Hmm. I'm so confused. If there's anybody watching who has any idea what the fuck I'm doing, that'd be fantastic. Um, Let me see here. It's bx plus cx minus c. Well, this is frustrating. Let me try this. Okay, can I guess numbers that are gonna work? So we got 3 halves plus 3 halves. That's gonna be 6 halves. So this is gonna have to be equal to 0 collectively. So if that was 1 minus 1, that would go away. Plus 1 would work, but probably not really. What bummer. Yeah, I must not have did this right. That's crazy. I swear that was how I learned how to do it. And that's definitely how the fucking tutor told me to do it. Sorry for my language. It's just so frustrating. It's like, come on, what in the shit? I'm like 100% sure I did it exactly the same with the tutor. And she was just like, oh, nope, see? It's just because we plugged into a different equation. All right, well, I'm going to have to go watch a video on it and try to do more tonight, I guess. And now, since I couldn't figure out the doozy, now let's try to figure out the real doozy. This one's a whole lot of fun. The first thing we get to do is say the degree of x is higher on top than it is on the bottom. So we can't just make partial fractions out of this. We have to first do long division. So for this method, we're going to put our denominator over here. And it's been so long since I've actually done like real long division that I don't know if this is, maybe this is exactly the same as that, but it sure feels different. Oh, okay. So we have x cubed plus x. So we're going to have to account for every power of x that we don't actually have. I think we can maybe get rid of that. I don't know. We'll see. Let's give it a go. So the first thing we do is we take, okay, x cubed is our first term. So we're going to say what times x squared is x cubed? And the answer is x. So now we're going to take this number, this number, and we're going to times it by each of these. So x squared times x will become x cubed. Then we have x times x, which will become 1 of x squared. And then we have 1 times x, which will just become x. Now we're subtracting this expression, which is going to cancel out our x cubes and our x's. And then we are going to be left, we have 0 of x plus 1 of x. It's going to, x cubed is going to just become, not x cubed, x squared. It's just going to become 1 of x squared. So now we're going to do our next round. So first thing we're going to do is we're going to say what times, oh, I'm sorry, I forgot to distribute. I knew I was doing something wrong. So since we have this whole expression in parentheses, that means that these that these positives actually become negatives. Like we're saying x3 minus x3, 0x squared minus x squared. So we're going to have minus x squared. Then we're saying positive x minus x. We're going to have 0. All right, let's do this again. On to our next round. We have what times x squared makes negative x squared. And the answer is going to be minus 1. So now we're going to say negative 1 times x squared is equal to negative x squared. We're going to say negative 1 times x is going to be negative x. We're going to say negative 1 times positive 1 is going to be negative 1. Okay, but this whole thing is in parentheses, right? So we're going to say, wait a minute. Okay, just kidding. Okay, let me go ahead and do this the right way. So negative 1 plus x is going to be negative x. Negative 1 times positive 1 is going to be negative 1. All right, there is our expression in parentheses. Now we are subtracting this expression, so a minus and a minus becomes a positive, so negative x squared plus positive x squared indeed cancels for us. However, that's it. But we still need to distribute, so a negative times a negative x is going to become positive x, and a negative times a negative 1 is going to become a positive 1, which means this is our remainder. Let me get rid of some of this stuff. All right, that is what we call long division. So now using the work that we just did, we're going to rewrite our integral as x minus 1 minus the integral of x minus 1 over x squared plus x plus 1. And I got my sign wrong. This is going to be plus x minus 1 plus. Okay, right, because this is the equation that we just found, but then this is its denominator. I'm like thinking about it. I'm sure it is exactly long division, like we do it with normal numbers, but it's just not normal numbers. So now this becomes a little bit easier for us, at least some of it does, because we can split all these integrals up. Okay, so let's just go ahead and start integrating. We've got x. We're going to add a power, so it's going to become x squared over 2 minus the integral of 1 dx will become x plus our integral of x minus 1 dx. Okay. In order to be able to do a use substitution here, we're going to have to say we need our derivative for this to be up here. So what do we have to do that? That means our derivative has to be 2x plus 1. So we can manipulate that to be 2x plus 1. We can times by 2, divide by 1/2. I think. Let's give it a shot. No, we want it to be 2x plus 1. Just kidding. Fucking A. So we're going to have to times by 2 and add 1. Did I do that right? All right. So we can make this into a 2x by pulling things out of it. So let me just go ahead and rewrite the rest of the expecting. I need to make this smaller. I'm so sorry. Gosh dang it. It always does that to me. All right. So now I think it should still be legible. Okay. Ugh. Okay. Let's go ahead and just move this up here. Fuck it. Make you a little smaller. Just pop you up here. Get rid of our top heavy. So let's turn this into so looks like we could do this way. Pull out a negative 1/2. So then when we times this in here, this becomes positive 1 of x. And but negative 1/2 times 1 is going to become negative 1/2. And negative 1/2 plus 1 does not turn into what we want it to 1. So let's go ahead and just take 1/2 out. Keep this minus, and keep the 1 outside positive. And so now we go 1/2 times 2x becomes x, and 1/2 times negative 1 becomes negative 1/2, plus 1 becomes positive 1/2, which is not what we want. So it's still not right. So we are still going to have to pull a negative out and keep what's inside of it as 1. Actually, here we're going to have to do it backwards to try to make it look like we want it to, I think. I think that's what we're going to want to do because it's all about trying to get our derivative. So I think I have it right. Let's just keep going here. I swear sometimes I have okay handwriting and sometimes it's just the worst. It's almost snap time for me though. Okie dokie. Let me see if I can get through this problem. I'm like, how many times am I going to write this? This has to be the second to last time. We're going to integrate on this one. Well, okay. I guess we're not going to integrate on this one. Well, let's do it. Just do it over here. So we can bring that negative 1/2 out front. So we can just go ahead and turn that into a negative, I guess. And just, well, no, we're not going to write 1/2 yet. And so what that is going to leave us with is negative 1/2 times the integral of 2x plus 1 over this expression minus 1 over that same expression. Let's see here. Let me see if I can condense my space. Let's see if I have this right. Okay, I'm doing this right. Sorry, I'm making myself nervous here. So the reason that this became a plus sign is because I had to distribute it, because the negative 1/2 is on the outside of the whole thing. Negative 1/2 times 2x plus 1. That all becomes, oh shit, but that would make a negative 2x. No, that would make it a negative x. We don't want that to be a negative x. Alright, bear with me here. Oh no, I gotta go. Alright, so I was fucking wrong. Okay, this is still 1. But this is going to be plus 1/2. Because 1/2 times 2 is 1x plus 1/2 plus 1/2. That would keep it the same. Okay. Right. Oh no. Yeah, 1/2 plus 1/2 is 1. To be minus. Is the remainder not x minus 1? Ay, ay, ay. No, the remainder is x plus 1. Gosh. Silly, silly, silly. Well, that makes life easier. So we have 2x plus 1 in the top, which is going to be equal to 1x plus 1/2 plus 1/2 would be equal to 1. So it would be x plus 1 over x squared plus x plus 1. So now we can break this up further into 1/2 times 2x plus 1 over x squared plus x plus 1. And then we can do plus the integral of 1/2 over x squared plus x plus 1. So let's integrate this one. U is equal to, I mean, I guess we don't really have to pick a new u. We have a u. So we can just want to rewrite it again, but I'm so sick and tired of taking up so much space. Okay. Okay. We're just going to rewrite it one more time, hopefully before the answer. So we have 1/2 times u prime over u plus the derivative of 1/2 over u. So these ones are pretty easy because we can bring the 1/2 out front. And then we have 1 over u times u prime, which is going to become the ln of the absolute value of u times 1/2 plus, we can pull this 1/2 out front also because we don't need to take its derivative or antiderivative. And then we have 1 over u again, so it's just going to be plus 1/2 of ln of u plus c. I don't think I did this right. Let me see here. I'm so lost. I'm so lost. Oh my god. I thought I had it, but there's no way. I don't understand. That seems like this should be right. X squared over 2 minus x minus 1/2 times. Oh, but maybe we can't there because we don't have u primed on top. Fuck. Well, like I said, real doozy. Um, I'm in groups in my class, and we're all supposed to answer 5 questions per assignment. And of course, not of course, but they assigned me the harder ones, and now I'm just trying to get through it. Fucking baffled though. Okay, so we've got 1/2. Okay, so I'm right up until there. Oh, okay. I'm not giving up. I'm not giving up. Just joking. Okay, so this first one, oops, this first one is gonna be um calculatable because it is, like we said, the u prime over u scenario. So it's just gonna turn into 1/2 x squared plus x plus 1. 1/2 times ln. And that should be right. And then, all right, let me see if I can succinctly write this down. Thank you so much. I am Aubrey Digital and I am learning calculus. So now we can say x squared over, oops, x minus, wait, okay. We're gonna try to do this one again. So we have this 1/2, which we're pulling outside of the limit or out of the integral because it's a constant. And then we're left with 1 over x squared plus x plus 1. So we're going to have to complete the square here because this doesn't factor. So, like, if it was, I think that would actually factor because the half would be 1 and then squared would be 1. It's funny. Anyway, so it doesn't factor because you can't say half of that and squared, and then it's that. I don't think so. I think that's completing the square. I think. I don't know. I'm this stuff. blows my mind sometimes. It is really, really fucking cool though, and I really want to become a master of the arts. I want to become a master. Okay, so what we can do here is we can say, oh yeah, so we do want to complete the square. So half of 1 is 1/2 squared is going to be 1/4. So in this case, we're going to add 1/4 and minus 1/4 from the denominator so that we do not change our equation, but no. Wrong again. Oh, okay. Just kidding. So we're going to add 1/4 because that makes this a perfect um, factorable term. But then there's 1 plus 1. Okay, so we already had a plus 1, and then we added 1/4 to it. Or no, we took 3/4 out of the expression. So now there's 3/4 out here. Oh, so wait. We didn't really have to change anything about our expression. We just had to, okay. So since this didn't factor nicely, we were able to just um, pull 3/4 out of the expression so that it would factor nicely. And then we should have 1 over x plus 1/2 squared plus 3/4, which should give us another 2 integrals. Again, I think the tutor did this wrong. Because you can't do that. That's an expression, I think. This is some shit. I'm sorry, y'all. I'm trying. So confused. Okay, I'm sorry. I have to give up again. But we got one more piece of it. Okay, well, I'll be back later to work on this some more after my music stream tonight at Aubrey Digital. Thank you so much for your love and support. See you tonight. Bye bye. Damn, I wasn't even playing music the whole time.